Good evening, everybody. I want to talk a little bit about amplifiers. With this new solar cycle, we have a lot of newcomers and we have a lot of old timers that they are removing the dust of this high amplifiers that they have for a long time. And those newcomers, they want to sound as good as old timers. A lot of people don't understand that it requires money, time, and dedication to obtain a good sounding equipment or station. But I want to talk a little bit more about amplifiers. I noticed that it's a lot of miss or hidden information from the consumer, and I'm here that I would like to clarify things that no one I have seen talking about this. But I would like to help those that are wanted to get an amplifier. In the CB world, we are used to 2 transistors, amplifier, that give us at approximately 4.5 volts between 350 to 450 watts. Okay, this is a 14.5 volts. Most semis, they have 14 point plus volts, up to 3 I have seen. Okay, 14.3 volts. Let's say this is the max that you're gonna have in a semi. In a regular vehicle, you're gonna have 13.8, 12.8. 12.8 I think is the most, and you're not gonna obtain 350 watts. This is in a full 100% efficiency of the 2 transistor amplifier. When you have a 2 transistor amplifier and you want to run 350 watts all day, you're abusing the amplifier. Okay, you are abusing the amplifier. One of the things that we have to consider is that when we test an amplifier here in the station, that I'm going to sell an amplifier or 2 transistors, I show them what is capable to do the amplifier. Okay, I'm going to show you the maximum output of the amplifier. That doesn't mean you're going to be using the amplifier at all times at 350 to 450 watts. Why? Because you're going to have a lot of heat in the heatsink, and I have a small heatsink here. This is very small. As you guys can see it, this is very small. This is an inch. This is very small for the amplifier. Okay. And it heats pretty quick. The dissipation in aluminum, it's longer than copper. Okay. When we use an airflow into the heatsink, the speed ratio to cool that piece of metal, it has to be a very high CFM. And most of the people, when you put a high quality or high capacity fan on their amplifier, they don't like the noise. That's the problem. And they ended up putting a 100 ohm resistor and ground to lower the speed of the fan. And what happens? They don't have enough airflow flowing into the amplifier, and they're gonna burn it. So my recommendations, when you order an amplifier and you want to run 350 watts, get a 4 transistor amplifier. Okay, get a 4 transistor amplifier, and I explain to you guys why. If you wanted to run, you guys have seen some of my videos, and I'm sure you guys have seen Gatekeeper Tom videos or BBI's videos. You guys can see that they show you the 350 to 450 watts and the 2 transistors on 757 out of Colorado. You guys notice that 300, but this is in a maximum capacity. If you're gonna run two transistor amplifier, run it at 250 watts. Okay, you're running about 60% of the amplifier, and that's just acceptable. You can run it all day, good quality of fan, and you should be fine. But this is gonna be your maximum power on the amplifier if you want the amplifier to last for a long time. Otherwise, you're gonna start burning the amplifier from the inside out. Okay, when you have a HFE of 38 and you're running your amplifier at 14.5 volts and you're running your amplifier at 350 to 450 watts for 3 minutes, I assure you that we can remove the transistor and the HFE. It's gonna be around, I would say 28, 29, because the temperatures are rising really quick and you don't have enough airflow to lower it. But if you're running at this, the heat is less. The speed of heat and the heatsink is going to be slower than running at 350 watts. Okay, so if you're running a 4 transistor amplifier, we show you that it can run 800 plus watts. Okay, this is at 100% efficiency. So if you run this amplifier at 600 watts, okay, if you put a radio that it does 35 to 40 watts PEP, okay, that's gonna give you about 600 watts. You leaving enough room that's between 60 to 70%, and you leaving 30% of the transistor alive. That's 30%. You can run an amplifier with at least 130 CFM for quite some time. You can carry a nice conversation on an HF band. So keep in mind that if you want to run more power, you have to consider these things. You have to consider your voltage, and you have to consider how much power are you planning to put out there. If you want to run 1000 watts at all times, okay, if you want to run 1000 watts at all times, you have to get a 12 pill, at least. I'm sorry, 8 pill amplifier. Okay, because you're gonna have enough room. If this one is giving you the 4 transistors 800 plus, 8 times 2, 800 times 2 is gonna be 1600. This is at 100% efficiency. By leaving the 600 on site, because the box is going to be bigger, the heatsink is going to be bigger, it's going to maintain the amplifier at 1000 watts very, very good, and a good temperature. You're going to have 2 fan in there that is going to give you at least, I would suggest for an 8-pill amplifier, at least 250 CFM, okay, airflow on both of them. It's going to be above 35 dB noise. The noise level. So when you order an amplifier, sit down, think about it, and say, I would like to run to 150 watts. Okay, great. Then you understand that you're going to go for the 2 pill. Okay, I want to run 600 watts, 500, 600 watts. Then you're going to get the 4 transistors, okay? Because you're not going to run at 100% to obtain 800 plus watts. It would do 1200. I done 1200, 1100 watts out of 4 transistors. For how long? Not for long at all. Not for long. Now you're going to run 1000 watts. Run it with the 8 pill amplifier. It's going to cost more money. But you also have to consider one more thing. What is the mode of communication you use in the amplifier? If you're going to use AM, let's say you're going to use, on the 2 transistors, you're going to use 35 amps. That's an example. Okay, amps. This is the consumption of a two transistors. Okay, Now, if you put bias on it, depends what type of bias. But most of the bias with the 15 ohm 10 watt resistor, your temperature on the resistor is going to be super fast. You guys can monitor it. I done this before, and that's what I want to give an advice for those that there are getting into the hobby, and those that are been in the hobby, they don't really consider all these things. Now, this resistor is going to create so much temperature. The temperature is going to increase so high that it's going to lose its value eventually. Depends how you run it. Depends how much airflow you have in there. Okay, but if you monitor this resistor temperature, it gets extremely high and extremely fast. Why? Because when you talk in an SSB, lower sideband or upper sideband, when you talk in this mode of communication, your amperage increase about 30 to 40%. So you be running on a 2 transistor with bias approximately 50 to 60 amps consumption. Okay, that means the more current, more temperature. It doesn't matter if you're still on 14 or 12 volts. The more current that flows to the transistor, the temperature of that transistor, the temperature of the heat sink is going to increase super fast, super fast. You don't have enough airflow, it's going to stay there. It's not going to bring the temperature down, especially the type of design that we are using in the boxes. We have, let's say this is the heat sink, right? This is the box. This is the box. We have the front of the amplifier and this side, and this is the rear part. We have the fan in here. The air flows through here, comes in here, and it flows through and it goes out of the amplifier. This is a good way to do it. However, the space that we have between the box and the components with the heatsink, if you put in, let's say, 100% airflow going in there from the fan, at least you've been rejected about 30 to 40% airflow coming back out. You put your hand up here above the fan and you can feel the air coming out from the amplifier because it just bounced back. Whatever it can goes back in here, cools the amplifier, so you lose it. You're getting about 70% only of airflow in here. So if you have 100 CFM on airflow, at least you getting into this section right here in the heatsink, you're getting about 60 to 70%. Okay, and we're talking about already about 28 dB up and up. This is dBA noise. So my suggestion is to pay attention in what do you want. I know it's this equipment is expensive. It takes a lot of time. For me to build an amplifier, I'm building an amplifier right now, a 5 transistors amplifier with bias and everything. It's going to be 3-in-1. If you guys have seen my video, 3 amplifiers in 1. It's a pretty neat design and the way that I do it. But at least I put over 15 hours of work in the amplifier. So it's not cheap. And the way that I do my amplifiers, it's not a factory. I do it as when I talk to the customer and I ask the customer, what do you expect from the amplifier? What do you want from the amplifier to do? I have these conversations and most of the customers, I explain to them the cost of it, and they think about it and they say, you know what, I want to go with a little bit higher, because they never thought about it. They think they're going to be running 350 to 450 watts all the time. They think they're going to be running a 4 transistor amplifier at 800 watts. They can't do this all the time. It's like your car can do 160 miles an hour, okay, but you're never going to run your car at 160 miles. The most that people do in the highway in a good day, 100. and it's with no cops around, right? So you're still leaving what, 40% of your speed. So you have to consider the same thing. If you're running an 800 watts amplifier, you gotta leave at least, in my personal opinion, 35 to 40%. Use only 65%, okay, or 70% of your, or the between 65 and 70. You don't have to be exact that percentage, but leave enough room for the life of the amplifier. So I want to share this with you guys because I noticed and no one really talks about, and I think it is important to understand when the newcomers are getting into an amplifier and they're so excited to get an amplifier. They pay $1,000 for an amplifier and they use it for 5 days and the amplifier burned. Why? Because they use a 4 transistors running at 800 watts, okay, and they want to run it at 800 watts like it's a cellular phone. They don't want to leave the microphone, and the temperature of those transistors, they're going over 135 degrees Fahrenheit, and boom, burn them. These transistors in here should be at least as 60, between 55 and 60 degrees Celsius. You guys do your math, guys. Convert this into Fahrenheit. We're talking about 130, 125 degrees Fahrenheit. This is nothing. I can run my LD MOS at 150 to 200 degrees Celsius. Okay, that's pretty wild. But I will never run my amplifier like this because I want my amplifier to last for a long time. I try to keep my amplifier less than 100 degrees Fahrenheit. Okay, I can run my amplifier, my LD MOS that I built, you guys have seen the video, but I can run that amplifier at 1200 watts that I get out of the amplifier. Okay, and I usually keep it between 65 degrees Fahrenheit. Okay, let me see, 65 degrees Fahrenheit, it will be approximately about 36 degrees Celsius, something like that. Not exactly, but it's near that. Okay, so I don't want to run. I've been pushing it to 120 degrees Fahrenheit. Okay, but this is nothing. That transistor can hold heat. Those transistors I use for laser machines, for MRI machines, you know, they can handle the heat. They really can handle the heat, but don't push them, because you push it and you're gonna burn the transistor, and they're not cheap. These 4 transistors, we're talking about let's say $100 or $140, $130 for those transistors, because you know you had to include shipping. You know, when you wanted a transistors to be replaced, they're not going to charge you only for the 4 transistors. I had to charge also for the shipping cost because I pay out of pocket, so it comes expensive, and on top of that you have to charge labor. So I want to give these tips for those that wanted to get into the hobby, to consider when you buy an amplifier, and not only for an amplifier, you also have to consider when you buy a radio, a multi-band radio or CB radio, what do you expect from the equipment to be used. You know, like years ago when I got into an antennas, and I analyzed many antennas, and I read so many books about antennas that it is very difficult to understand. But one thing that I recommend everybody is, what do you expect from it? What are you expecting from an antenna? You can get a quarter wave antenna, half wave antenna, 3/4 wave antenna, 5/8, 164. What are you expecting from that antenna? That is the answer. How are you planning to use the antenna? Same thing with the amplifier. And right now I want to focus on the amplifier because I think it's very important I was talking to a gentleman the other day that it was running the amplifier with 90 watts. Okay, 90 watts, and it was running his 4 transistor amplifier. So with 90 watts, yes, you're gonna get 800 plus watts. Right? For how long you gonna run this? He already in our conversation that we have, it's if I use my amplifier in 90 watts, the 4 transistors they get weaker. Instead of doing 800 watts, you start getting 600 watts, and then you will move to 400 watts, 500 watts, 300 watts into those transistors are useless. Okay, and that's when I talk about the HFE up here. When I talk about the HFE, HFE, you have multiple transistors inside a transistor, right? You have all these transistors inside the transistor. It's like a pill like this. This is a transistor, okay? Emitter, base, and collector, okay? So you have all these transistors inside. What happens when they get really hot? They start burning. So instead of having, let's say, 22, now you have 1, 2, 3, 4. Now you have 4 burn, then you have only 18. Why? Because you're running 90 watts for several minutes, and this is getting weaker and weaker and weaker. So if you want to run 1,000 watts, get a 8 transistor amplifier. If you want to run 600 watts, get a 4 transistor amplifier. And you want to run 250, just get only a 2 transistor amplifier. I hope this information helps someone to understand that getting to the CB world is not only just get an amplifier, plug it into the radio and use it and burn it in the blink of an eye. It's not that simple. It costs a lot of money. It cost me, I've been in the radio business for over 20 years, 24 years, I think. And I spent a lot of money. I have no mentors to tell me what not to do. I learned the hard way. And my wife has been supporting me all this time because I try to teach people that what they have learned from other people, it's wrong. I'm sorry, but it is wrong. And it's hard to accept sometimes that they have been taught the wrong way. Because when I put the numbers together, numbers don't lie. The numbers don't lie. Okay, so keep in your mind, guys, that getting into in the amplifier world, once you put an amplifier behind the radio, you have to consider heat, airflow in your amplifier if you want that amplifier to last you for a long time without burning it, without spending money on it. And what I'm saying here is, I don't care about this business. I do not care about me building amplifiers. I care about those that wanted to learn the hobby and enjoy it. Because when you burn an amplifier, you're not enjoying the hobby. You want to get out of you burn the amplifier in a year 3 to 4 times, you're not enjoying the hobby at all. So my message here is, be aware of how an amplifier works. And one of the most important things is, what are you expecting from the amplifier? Whoever is the builder, talk to him. Explain to him what are you expecting from the amplifier that he's going to build for you and how you're planning to use it. That way, if it's an honest person, the one that's building your amplifier is going to tell you, I recommend you to run an 8 transistor amplifier. I recommend you to run a 16 pin amplifier. The more that you go up, the louder you want to sound, the more money it's going to cost you. And that's part of the game. If you want to sound really loud, you need to spend money. And money at this time of our times where we are in a recession, it's tough. So I'm giving the advice to those that wanted to get into this to want to put an amplifier behind the radio, to consider all these points. I think they're very, very important. I talk about the efficiency of the amplifier, how much percentage you should be using of the 2 transistor or 4 transistor or 8 transistor amplifier. I talk about the how many watts are you planning to use your amplifier with and not hurting your amplifier. I talk about the voltage on your amplifier. The higher the voltage, the more watts the more current it's gonna go. The higher the current, the higher the voltage, the lower the current. Okay. I talk about temperatures. I talk about airflow. I talk about HFE, and I talk about bias. When you have a bias, your amplifier is gonna run hotter. The heatsink is gonna be hotter because when you have bias, it's more current. Keep in mind, if you're gonna use an amplifier strictly in AM, there's no point for you to get bias. You can use your amplifier in Class C all day long. In AM, you're not gonna hear the distortion of the amplifier. Now, if you move to sideband and you try to talk with a Class C amplifier, this is a different ball game. When you are in sideband, you must have a Class B or a Class AB amplifier. Okay, you have to consider those things. C is only for AM. B and AB is for SSB, single sideband. Okay, so I hope this, and I talk about the life of the HFE and the transistors that we have inside a transistor. Okay, so I hope this information, I think the video is already too long, it's 26 minutes long, but I'm excited, and I hope if you are here at the end of the video that this information is helping you, because it's very, very important. 73 guys, and I hope you enjoy the hobby.